Good morning to all of you children. Yesterday I would have seen the basic things related to magnet. After knowing all the basic things related to magnet, we will be able to understand the chapter we have to study, that is magnetic effect of electric current. Now today I am going to start the next step of this chapter. First of all, the simplest one is magnetic field. So if we have kept a magnet here, suppose this one is the bar magnet, okay. Now around this bar magnet, there will be some limited space where its influence can be seen or felt. The space around the magnet till where its effect can be felt, its influence can be felt, is called magnetic field. Suppose if it would be the powerful magnet, then its influence would be for longer distance. But if suppose the magnet is not so much of powerful, then its influence won't be till long distance, large area. So that is magnetic field. Okay. Now another term related to this one is magnetic line of force. Magnetic line of force or lines of force only. What we say it? Magnetic line of force. Lines of force or only field lines. Okay. So after explaining this one, I'll show you an activity after this video. After this video, you will see the next video in which I will show you the magnetic line of force by doing activity. So that will make your concept more clear. So first of all, let us see here. Like I would have explained, you would be knowing that conventionally the positive charged object is said to be at higher potential. Positive charged object is said to be at higher potential and direction of current conventionally is from positive to negative terminal. Positively charged place, positively charged point to negative charged point. Okay. That is conventional. Actually, which particle flow? Electrons flow. But the direction of current is taken from positive terminal to negative terminal of the cell or positively charged body to the negative charge. Like the same way, it is also conventional that north pole of magnet is taken to be at higher potential. So its influence is shown from north to south direction of magnet. Okay, that is conventional. Nothing is like that. It is important that we had to take this north pole at higher potential, but they are just like conventional. So this is the conventional that north pole of magnet is taken to be supposed to be at higher potential. Now you will pay attention nicely to understand this topic, children, because the whole thing in this chapter, magnetic effect of electric current, is based on only magnetic line of force. Everything. So let us understand this topic nicely. Okay. Suppose we have this one north pole and this is the south pole of magnet. Okay. Now we keep a magnetic needle near the north pole. Magnetic needle. Suppose we keep magnetic needle here near the north pole of magnet. Arrow will represent north pole of magnetic needle. So what will happen that the north pole of this magnet will attract south pole of this magnetic needle. This is south pole and this is north pole. So north pole will attract its south pole being closer to it more force of attraction will be there. So this end of the magnetic needle will be attracted towards this north pole, but the north pole of this magnetic needle will be repelled by this north pole, and also it will be attracted by this south pole. This south pole of magnet will attract this north pole, and this north pole will repel it. So if I ask you, whose force will be acting on the north pole of magnetic needle in more magnitude? Whose magnitude will be more? North pole being closer to it, it will exert more force of repulsion here, but south pole at large distance from this north pole, so its force of attraction on it will be less. Okay, so what will happen that due to its force of repulsion, the north end will go this side. Now we will mark the two end of magnetic needle, then we lift it, or suppose we don't mark it, just we will see the direction in which the north pole of this magnetic needle will move. I will go on moving the magnetic needle, the direction in which north pole will go on moving. So why it will happen that, why I am telling this thing, that as the magnetic needle will go little bit away from this magnet, then from this magnet, not I will say you north pole of this magnet, then its force of repulsion will go on decreasing, but force of attraction of the south pole will go on increasing. So due to that reason, what will happen that north pole will start moving along this line, means we will leave the north pole to move freely. So the north pole will move along this curved path. We will see it. I will show you again in next video just now. So the north pole of this magnetic needle will move along this curved path, and finally over here what will happen that the force of attraction of this south pole on the north pole of magnetic needle will be more, and force of repulsion of this north pole on the north pole of magnetic needle will be less. So finally the north pole will come over here following this curved path. So what is that curved path? The line along which the magnetic force of this magnet act on the north pole of magnetic needle. North pole of magnetic needle is free to move. So what happens that due to the force of repulsion of this north pole and force of attraction of this south pole on the north pole of magnetic needle, the magnetic needle will move along this curved path, and this curved path we are getting is called magnetic line of force. Is it clear, children? I think you would be understanding this thing. Again, if we plot another magnetic line of force, by doing this, magnetic needle will be kept over here. North pole will come this side, south pole will be over here, because force of attraction of this north pole on the south pole is more than the force of repulsion over here. Now north pole will come this side. Again we will move the magnetic needle here. North pole will come here, south pole will stay here. Again magnetic needle will become parallel to the magnet here. Again north pole will come this side. So we will get again the curved path, which is the line along which the force of this magnet due to the north pole and south pole, the force is exerted on the north pole of magnetic needle and it moves along this curved path. This curved path is known as magnetic line of force. The line along which the force of repulsion by this north pole and force of attraction by the south pole act on the north pole of freely moving magnet is called magnetic line of force. I think you would be becoming clear. You will be getting clear concept of this one, children. I expect this thing from you all. Now, as this magnet will have magnetic field, but the strength of the field will go on decreasing as we move away from the magnet. So what will happen that we will have more magnetic line of force over here. And at the two end of the magnetic line of force will appear to be like this, diverging from the North Pole and converging, getting inside towards the South Pole. Because if we will keep the magnetic needle here and we will mark its north and south pole little bit away from the North Pole of magnet, we will get these lines, but these curves won't be completed because the effect of this magnet is not reaching till here. So we won't be able to complete this curved path. Only these lines will appear to diverge here, and these lines will be converging over here, will appear to diverge. What we are considering the North Pole as at higher potential. So we will show them field lines emerging from the North Pole and ending at the South Pole. Is it clear, children? The diagram is given in your book also. I will show this activity again. We will keep a magnet on the plain paper on the drawing board, and then we will sprinkle some iron filings around it. Iron filings, small pieces of iron like sand. So we will sprinkle iron filings around it, and then we will struck it like this. We will find that all the iron filings get arranged like this. This diagram is given in your book. Also, these iron filings get arranged along this curved path. Because children, you will say that you can ask me that iron filings are not magnet. So why it happens? So children, before this topic, I had to explain that one. In presence of magnet, if we bring a magnetic substance, what happens that magnetic substance get magnetized. Their domains become collinear. Okay. So by the process of magnetic induction, this magnet induces magnetic property in iron filings, and they also start behaving like a magnet, and so they get arranged along this curved path due to the north and south pole of magnet, and we will get the same thing, magnetic line of force around this magnet. So either by this way, putting magnetic needle around this magnet, or sprinkling iron filings around the magnet, we can show the magnetic line of force. And I think you would have understood about the magnetic line of force, children. So as a whole, what we can say, the magnetic lines of force are imaginary closed curve, which emerge from the north pole of magnet and end at south pole of the magnet. Okay. So these are the magnetic line of force. We cannot see magnetic line of force. They are not visible. Only we can see its effect. Okay. Now let us recall some properties of magnetic line of force. Okay. So first property of magnetic line of force, children, I am speaking slowly so that you can write also. Magnetic line of force emerge from north pole of magnet and end at south pole. Is it clear? And inside the magnet, its direction will be from south to north because they are closed curve. Magnetic line of force emerge from north pole of magnet and end at south pole. Now outside the magnet, but inside the magnet, they move, their direction taken from south to north pole. One property. Next one, magnetic line of force never intersect each other. Children, it can create little confusion in you. So, and this is also the important topic related to magnetic line of force. Magnetic line of force never intersect each other. It means what? As we studied that magnetic needle will move along this path. Anywhere if we keep, north pole will be moving along this direction. So if the two field lines intersect each other, it means at this point magnetic needle has two directions. Is it? Magnetic line of force if intersect each other, it means at a point the magnetic needle has two directions. That is not possible. So what happens that magnetic line of force never intersect each other. Good. Third point which we need to know, that degree of closeness of field line represent the strength of magnet. Closer are the field lines, stronger will be the magnetic field. So at the two ends of the magnet, field lines are very close. But if the magnet is strong, then a degree of closeness of field line represent the strength of magnet. If the magnet is stronger, then field lines, if we will plot, they will be closer to each other. Is it clear? So these three properties are there in our book, which we studied. But children, if you want to know little bit more than this one, as we have studied that north pole of magnet means like pole of magnet repel each other and unlike pole attract each other. So how we can explain this one? So this is based on a property, that is that magnetic lines of force are like the stretched rubber. Stretched rubber, children, I am showing you. Stretched, these are like the stretched rubber. If we stretch, they pull this rubber from this side, both sides, what will happen that its length will get elongated, but it will try to contract along its length. Okay, its shape has deformed. So the field lines are like the stretched rubber which wants to contract along its length. So suppose we have two magnet and opposite pole of magnet. So field line of north pole of this magnet is like this, and south pole will have this kind of field lines. So what happens that these field lines join with these field lines at this end of the second magnet. They form the closed curve. So as I told you that they are like the stretched rubber which want to contract along the length. So these field lines will attract each other, will try to contract along its length, and then so there will be attraction between the opposite pole of magnet. Now the next one, that like pole of magnet repel each other. These are the two like pole of magnet. And the property of field line is that field lines try to push other field line sideways. वो बगल की ओर उसको push करता है. Then due to that ये इसका field line इसको आगे पीछे push करेगा और इसका field line इसको पीछे की ओर push करेगा. Okay, so what will happen that these field lines repel each other, they push each other sideways, and due to that there is repulsion between the like pole of magnet. So these 2 points were a little bit more than the topic of the NCERT. So children, today we studied about what? Magnetic field, then magnetic line of force, properties of field lines. You will do these things nicely and understand these things nicely. Not like that I am seeing the video of Miss, so you will study these things properly, and you will take little bit advantage of my effort. I am so much fond of this thing. So children, you see nicely and understand, and after that you know what I want to tell. So fulfill my wish and listen me also. Thank you so much.